Hello, this is Mrs. Clark. Today is Friday. Happy Friday, you guys. What a crazy week it's been. I'm glad you're here joining me today. At this point, when we're working on our instructional slides, I believe with all my heart that you have been through um, several other things before you have started this video. So we started Friday with two letters. One's in English and one's in Spanish. This is just a family letter letting the people in your family know what we are working on with lesson 2. Now we just finished up with lesson 1. Lesson 1 had 5 sessions in it. This lesson 2, has only 3 sessions in it, so it's a little bit shorter. What you should have done already is done the do now and submitted that and worked through the instructional slides. Now, what those slides are walking you through is the problem that we'll start with today. And you were looking at the problem in several different ways, hopefully typing in your responses as you went through, just like we would do in class. So at this point, we are to the instructional video. So we're going to be doing this video together. While you're working on the video, you're going to have your Chromebook side by side with your math workbook. And we're going to be on page 33 in your workbook, the page that looks like this, with that cool weaving there on the side. And let me get things situated here. I am going to share what my document camera sees. There. All right. Have any of you worked with yarn before? Have you ever done weavings, or have you done any knitting or crocheting or making little pom-poms or other kinds of crafty things? People have worked with yarn in a variety of ways for millennia, forever and ever. And the picture here, right here, shows us an example of Navajo weaving, which is so cool. In our book, it shows this, and it talks about Native American tribes using different weaving techniques, and this is a pattern that is known to be Navajo. So it's pretty awesome. We're from the Southwest here, southwestern Colorado. We've got a shout out in our math book. So we're awesome. They're awesome. So let's read through this. I know you've read through it several times as you worked through the slides, but I'm going to read it once with you, and we're going to highlight some important parts of this. So Grace weaves a rug that's 1/3 yard wide and 2 yards long. She wants to weave a rug that uses the same design, but is 1 yard wide. How long will the rug be? So I think this is pretty important, our dimensions of the rug. I think it's also important to know that she wants the same design. So what she's looking at is basically an enlargement of this very same rug. And then if it's a yard wide, how long is it going to be? So let's start out. Let me shift things around just a little bit. I want to make sure that we keep our problem right there at the top. All right. You know how I like to draw pictures, so we're going to first draw her rug. And it's 1/3 yard wide. So it's about 1 foot wide. And it's 2 yards long. Now I want you to think, let's see, I need to scoot again. Otherwise you're not going to see what I'm writing. There we go. Let's say that this is a yard. Here's 1 yard. And if I divide it into thirds, this is 1/3. This is 1/3. And this is 1/3. We know that there are 3 1/3 in a yard, 3 1/3 of a yard. So when I add up 3/3, I know that I have 1 whole. I also know that I can multiply 3 by 1/3 and also get a yard. That's what this would look like. So if I multiply 3 of these pieces together, multiply that by 1/3, look what happens. I get 3 over 3, which we know is the same as 1 whole. Just getting our fraction juices flowing a little bit here. So what we're going to be doing is creating a larger rug. Grace wants a bigger rug. This rug, she wants to be 1 yard wide. Put that way at the bottom. So this rug is 1 yard wide, and I know that there are 3 1/3 in a yard because we drew them up there. So we know that there are 3 1/3 yards in 1 yard. And basically what I did up here is I multiplied 3 by 1/3 to get a yard. So if I multiplied 3 by the width, I also need to multiply 3 by the height or the length of the rug. So I'm going to multiply 3 times 2 equals 6. And right here we've got 6 yards. So there we go. It's a different look of it. I wasn't sure if you were able to see that 1 yard at the bottom because I've got a little box on the screen. Okay, that's our first look at this problem. Let's flip over to page 34. So we've tried it. Now we're connecting it. It asks us to look back. How long is a rug that is 1 inch or 1 yard wide? Explain how you know. So let's just start with the rug is 6 yards long because we multiplied both dimensions by 3. So I'm going to write that down. The rug is 6 yards wide, 6 yards long because I multiplied the dimensions I'm going to even put rugs dimensions. Now remember, a dimension is a fancy word for length and width. The rug's dimensions by 3. That's how I know. So let's look ahead. See if we can see this. Grace's original rug has a length of 2 yards and a width of 1/3 yard. We know that. That's what we've been talking about. You can write the ratio of length to width as 2 to 1/3. To find the unit rate, you can start the complex fraction 2 over 1/3. Fractions in which the numerator, the denominator, or both are also fractions are called complex fractions. If you have a highlighter, this is the perfect time to employ that highlighter. I'm going to highlight this phrase, complex fractions. I'm going to highlight the example of a complex fraction. I'm also going to highlight the definition of the complex fraction. So like a complex fraction is a fraction on steroids. Instead of just a single number in the numerator and a single number in the denominator, there's a fraction in the numerator, or there's a fraction in the denominator, and sometimes there's a fraction in both. So that's like a super duper complex fraction. And A is going to tell us what we do with this fraction. So you can simplify a complex fraction by dividing. Since a fraction bar represents division, you can think of 2 over 1/3 as 2 divided by 1/3. I'm going to highlight that as well. It's important stuff. Think of, and I'm going to highlight just that little fraction bar and the divide sign. Then you can divide to simplify. What is the unit rate for the length to width of Grace's rug? What we're going to do is take that complex fraction, 2 over 1/3, and rewrite it as 2 divided by 1/3. And I'm going to change 2 into a fraction. 2 over 1 is the same as 2. I can change any whole number into a fraction just simply by putting it over the number 1. So what I have here is 2 over 1 divided by 1/3. Now I'm going to leave my first fraction exactly the same, 2 over 1. And when I divide something into thirds, it's the same as multiplying by 3. Remember, let's see if I've got this handy. Oh, right here. When I divided this into thirds, my one piece now has 3 parts to it. So I've actually multiplied my number of parts. So I multiplied that number of parts by 3. Scoot that back again. So I'm going to multiply instead of divide, and I'm going to turn this fraction of 1/3 on its head. So instead of 1/3, I've got 3 over 1. Now I've got a very easy problem to solve. 2 times 3 equals 6. 1 times 1 equals 1. And that's the same as 6. So what was the length? What was the unit rate for length to width? The unit rate is 6 to 1. Well, let's see. The unit rate of length to width so her new rug is 6 yards long. The unit rate is 3 to 1. The length is 3, the width is 1. This is our unit rate right here. And I'm going to bubble that all around. Okay, there's our unit rate. Problem B asks us to rewrite this complex fraction of 1/8 over 4/9. You know what? I love when we start working with fractions like this because we get to do put so many numbers on. When people look at us and see the work we're doing, they're thinking, oh gosh, those guys are so smart. They know how to do so many things. When I write these things on the board, I like to leave it there because as people walk into the classroom and they see all these fractions on the board, they think those 7th graders are so smart. And you are. So the fraction we're using here is 1/8 over 4/9, which is the same as 1/8 divided by 4/9. So we are going to take this problem and rewrite our 1/8, and we are going to multiply 1/8 by 4/9 standing on its head. So when I stand 4/9 on its head, it's upside down and it becomes 9 over 4. Then it's easy. 1 times 9 is 9. 8 times 4 is 32. And that lets us answer question C, which is, what is the quotient of 1/8 over 4/9? Quotient is a fancy big word. That means, what's the answer of this division problem? A quotient is the answer to a division problem. Remember that sum is the answer to an addition problem, product is the answer to a multiplication problem, and division is the answer to a subtraction problem. So a quotient, that's our answer. And let's just write the quotient is 9 over 32. And we're using that academic vocabulary. It's 9 over 32. Now we get to talk about a bug. Suppose a bug travels 1/2 a mile in 12 minutes. Write a complex fraction you could use to find the speed of the bug in miles per minute. They're telling us the order to go right here. It's miles per minute, miles per minute. The first quantity, the first amount, is always the numerator. So what's the bug's speed in miles per minute? So let's highlight what's important. Want the bug speed in miles per minute. Let's write 1/2 mile over 12 minutes. We've got ourselves a complex fraction. We've got a fraction in the numerator, a whole number in the denominator. We can rewrite this as a division problem. So I'm going to rewrite this as 1/2 divided by 12. And I want 12 to look like a fraction, so I'm going to place it over 1. And to solve this problem, I'm going to write 12, or 1 over 2, 1/2, multiplied by 12 over 1 standing on its head. So 12 over 1 on its head is 1 over 12. Multiply the two ones together. 1 times 1 is 1. Multiply 2 times 12 together. That gives us 24. So it goes, the bug goes 1/24 of a mile per minute. The bug travels 1/24 mile per minute. And there's our 1/24 right there. Okay, now we get to do some reflecting, which means thinking back over what we've done. They're asking us about two complex fractions. Are 1 over 3/4 and 1/3 over 4 equivalent fractions? And explain. What we've got here are the exact same numbers, they're just in different order. So let's take a look at it. I'm going to divide this page into half. This side, I'm going to work with the first complex fraction, which is 1 over 3/4. Now remember that we can rewrite this substituting a division sign for that fraction bar. So I've got 1 divided by 3/4. And I'm going to make this 1 into a fraction. So 1 over 1 divided by 3/4 is the same as 1 over 1 multiplied by the reciprocal, or 3/4 standing on its head. Reciprocal is a really fun word to say. It just means the fraction is upside down. So multiplied by 4/3. Multiply the two numerators together. 1 times 4 is 4. Multiply the two denominators together. 1 times 3 is 3. and you have 4/3. Let's check this other fraction, complex fraction, and see if we get an equivalent fraction or one that is equal to this. So I've got 1/3 over 4. I'm going to change this into a division problem. 1/3 divided by 4, and I'm making that into 4 over 1. So let's leave our first fraction, the 1/3, alone. I'm going to multiply instead of divide, which is the opposite operation, and I'm going to change 4 over 1 into its reciprocal, which is 1/4. Multiply the numerators together. 1 times 1 is 1. Multiply the denominators together. 4 times 3 is 12. And let's look at both of these. I've got 4/3 and I have 1 over 12. Now, what do you know about 4/3? Because it's an improper fraction, you know that it's greater than 1 whole. And what we know about 1/12 is that 1/12 is pretty small. Think about a pizza divided into 12 parts. You only get one of those parts. So these are not equivalent fractions. And I'm just going to write that down. These are not equivalent fractions. And we proved it. Our explanation is right here. Because 4/3 and 1/12 are not the same amount. All right, I'm going to shuffle papers again. And you're turning in your book to page 35. It looks like this. What we're going to be doing is doing some definition work with the word ratio. So we're going to prepare for finding unit rates involving ratios of fractions. So think about what we know about ratios and comparisons. We're going to fill in each box. We're going to use words, numbers, or pictures, and show as many ideas as possible. So I'm shuffling things around so we can see, trying to get it all in one screen, which is not as easy as I'd like it to be. Still shuffling. I know that I can do this. Okay, so a ratio. What is a ratio? That's where we're going to start. So we know from what the work that we've been doing with ratios that a ratio is a comparison between two quantities or two units. So let's put that down. A ratio is a comparison between two, and I should probably put or more, quantities, fancy word for number, quantities or units. So there's a couple of ways that we can compare these. We can compare part to part, part to whole, or whole to part. And that's always explained for us. It's always told what direction we're going to go. So what do I know about it? Well, I know that I can write it 3 different ways. Can be written three ways. And I wrote a 3 first. So I'm going to go backwards. I'm going to count down 3, 2, 1. So a third way that we can write it is, let's see, what do I want? Let's say that we're comparing 6 books to 12 kids. Another way we could write it is 6 books with a colon here, 12 kids. We could also write it so that it looks like a fraction. 6 books over 12 kids. And I know that this is a fraction that can be simplified. So if I divide 6 divided by 12, I'm going to get 0.5, 5/10, or we could call it 1/2. So our unit rate would be 1/2 book per kid. Poor kids only get half a book each. That's pretty sad. So here are some examples. Scoot that down a little bit. So let's think of some examples. Let's do a ratio of stars to smiley faces. And let's do 3 of them to 2. So here's 3 stars to 2 smiley faces. Pretty sad smiley faces. Okay. We could also say 50 students to 4 teachers. Let's do a food one. Let's say we've got 5 kids to how many cookies? Let's say 10 cookies. What would be our unit rate? How many cookies would one kid get if everybody gets an equal amount? Oh, that's making me hungry. We can also have it look like this, 65 miles per hour. Another way we often write it is like this, 65 mph, 65 miles to 1 hour. That's a lot. That's a lot we already know about ratios, and we're going to be using ratios quite a bit. Let me shift things down so we can work on this problem at the bottom. On a bookshelf, there are 5 paperback books and 3 hardcover books. Is the ratio of books to hardcover books 5 to 3? So let's draw out our picture. Here we've got paperbacks. And let's see if I can make these look like books. The first kind of look like books, but it takes me too long to draw those. And the second one doesn't look as good as the first one, so I'm just going to do boxes. And here's our hardcover books. And there are 3 of those. And it's asking, is the ratio of books to hardcover books 5 to 3? Well, it looks like we've got 5 paperbacks to 3 hardcovers, but what's our total? Our total number of books would be adding these together, 5 plus 3 is 8. So books is a total, like the whole to a part. So books to hardcover would be 8 to 3. 8 to 3 is the ratio of total books to hardcovers. Okay, so 5 to 3 would be the paperbacks to the hardcovers. 8 to 3 is total books to the hardcovers. All right, you are going to flip now to the iguana page, page 36. Actually, this is more like a gecko than an iguana. So this problem has to do with this lovely iguana sitting on the twig. And iguana, I said it again, this gecko sitting on a twig. This is on page 36. Muna is making a scale drawing of a gecko. Geckos are tiny, iguanas are big. So this gecko is 1/2 inch wide and 5 inches long. She decides to make her drawing of the gecko 1 inch wide. How long will the drawing be? And show your work. The next little bit of that is on letter B. Check your answer to problem 3A and show your work. This is what I'm going to have you do using I'm going to have you write it straight in your book first and working on your own, figuring out, and if you want to draw pictures of the gecko, that's really fun. And then you're going to transfer this to a CAMI assignment, CAMI document, and then submit it so I can see it and grade it. I need to reduce that. I'm going to stop my